Quadratic formula. The quadratic formula. To find the solutions to any quadratic equation of the form ax squared plus bx plus c equals 0, we can use the quadratic formula. So previously, when we had a quadratic equation, we factored and set each factor equal to 0. But if the quadratic cannot be factored, now we have the quadratic formula. So the quadratic formula is based on the values of a, b, and c. So the quadratic formula is that the x values are equal to negative b plus the square root of b squared minus 4 times a times c all over 2a. Or the second solution is everything about this first part is the same except there's a minus after negative b. So now it's negative b minus and then the square root part all over 2a. So this presents us with two different solutions. We can write it in compact form as x equals negative b plus or minus this square root part all over 2a. So let's go ahead and see a little bit more about how this would work. In these examples, we want to write each equation in standard form and identify a, b, and c. So in part A here, I have 3x squared equals x minus 2. Now to write the equation in standard form, we need to move everything to one side to set it equal to 0 in order to find the a, b, and c that we need. So that means I'm going to have to subtract this x to the other side and add the 2 to the other side. So in standard form, I have 3x squared minus x plus 2 is equal to 0. So again, subtracting the x from both sides and adding the 2 to both sides. So now this is in standard form, so I have the 3x squared part, so the highest exponent first, then minus x to the first plus 2 equals 0. And once it's in standard form, I can identify my a, b, and c. So here, the value that is in front of x squared, that is going to be my value of a. So a is equal to positive 3. The value that's in front of x, including the sign, is b. So what's in front of an x, we don't typically write it, but it is a negative 1. So b is equal to negative 1, again the value in front of just x. And the constant, positive 2, is the value of c. So this whole thing right here is the value of c. So let's go ahead and move on to part B. We have m times 5m minus 2, all in parentheses, equals negative 3. So we're going to have to distribute in this m and add the 3 to the other side. So if I distribute in the m, I get 5m squared minus 2m is equal to negative 3. And again, I'll have to add this 3 to the left side to set this equal to 0. So 5m squared minus 2m plus 3 is equal to 0. So our value of a is in front of m squared, our value of b is in front of just m, and our value of c is the constant. So we have a equals 5, b equals negative 2, and c is equal to 3. Now these two examples are getting us ready for applying the quadratic formula. Alright, in this example we're going to solve 3n squared minus 10n equals negative 8. So first we'll go ahead and set this equal to 0, so add the 8 to the other side. So we have 3n squared minus 10n plus 8 is equal to 0. And that will help us identify our a, b, and c. So our value of a, our value of b, and our value of c. So a is 3, b is negative 10, and c is positive 8. And now we're going to apply this to the quadratic formula. So just to remind us, I'm going to write the quadratic formula up here. So it's x equals negative b plus or minus the square root of b squared minus 4 times a times c, and this whole entire thing is over 2a. So really this is just a matter of substituting in these three values into the a, b, and c of this formula and simplifying. So we have x equals negative b, so I'm plugging in a negative 10 because b was negative 10, so negative times negative 10 plus or minus, we have the square root of b squared, so negative 10 squared. It's very important that we keep the negative 10 in parentheses and square that whole quantity. And then we have minus 4 times a. The value of a was 3, and the value of c is 8. And then this whole thing is all over 2 times 3, because again, the value of a was 3. So from here, let's go ahead and start to simplify. So across the numerator, we're going to have x is equal to negative times negative 10 is positive 10, plus or minus, we have, the square root of, so here we have negative 10 squared. So negative 10 times negative 10 is positive 100. And then here we have minus 4 times 3, that's 12, and 12 times 8 is 96. So we're going to have minus 96, so that's all underneath the square root symbol. And then over 2 times 3 is 6. So we have x equals 10 plus or minus the square root of 4, 100 minus 96 is 4, all over 6. So x equals 10 plus or minus 2, because remember the square root of 4 can be simplified to 2, and then over 6. Now this is a condensed version. This is two separate answers. So from here, I'm going to go ahead and split this up. So this becomes 10 plus 2 over 6, and then it also splits up to 10 minus 2 over 6. So those are my two different solutions. So 10 plus 2 is 12. So 12 over 6, that's 2. And then here I have 10 minus 2 is 8 over 6, which reduces to 4 over 3. So I have my two different solutions. I have 4/3 and positive 2 as my answers. Now, this was an option for solving this particular quadratic equation because this was a factorable quadratic to begin with. We just went straight ahead and practiced the quadratic formula, but 3n squared minus 10n plus 8 can actually factor. I'll see if I can squeeze it in here. So it would factor to a 3n and an n equals 0. So we're looking at, it's going to be 3n minus 4 and n minus 2 is equal to 0. So if I were to set each of these factors equal to 0, so if I were to add the 2 to the other side, I'd get 2. Here, if I were to add the 4 and divide by 3, I would get 4 over 3. So some quadratics have the choice to factor or to use the quadratic formula, but some don't. So if a quadratic doesn't factor, we call that prime, then we have to use the quadratic formula. In this next example, we'll solve m squared equals 2/3 m plus 4 over 9. So because this is an equation, the first thing I'm going to do is clear these fractions out by multiplying both sides by the LCD. So the two fractions involved have a 3 and a 9 as the denominator, so the LCD is 9. So I'm going to multiply both sides, or really each term, by 9. So I'm going to have 9m squared equals 9 times 2/3 m plus 9 times 4/9. So that leaves me with 9m squared equals, this 3 will go into the 9 3 times, so that gives me 6m. 3 times 2m is 6m. These 9's cancel, so I get plus 4. So now I still have to move everything to one side to set it equal to 0. So I'm going to have 9m squared minus 6m, I'll subtract the 6m, minus 4, subtracting the 4. So my values of a, b, and c are a is 9, b is negative 6, and c is negative 4. We don't want to forget to take the signs, the negatives, with us, or that will change our final answer. So let's go ahead and apply the quadratic formula on this one. We have x equals negative b, so again, negative times negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4, a was 9, and c is negative 4, all over 2a, so 2 times 9. All over 2 times 9. So let's go ahead, and from here it's just a matter of simplifying what's going on. So we'll work with the numerator. Negative times negative is positive, so I have x equals positive 6 plus or minus the square root of negative 6 squared is positive 36. Again, why it's so important to keep this in parentheses. So we have positive 36, and then here we have negative 4 times 9. That's going to be negative 36 times negative 4 is going to give us a positive 144. And then this is all over 2 times 9, which is 18. So I have x equals 6 plus or minus the square root of 180, if I add 36 and 144, all over 18. And now, what's underneath the square root isn't a perfect square. So what we want to try to do is simplify it using the properties that we did previously on simplifying radicals. So I have the square root of 180. What's the biggest perfect square that divides 180? So that happens to be 36. So what I have is x equals 6 plus or minus the square root of, this is 36 times 5, and then all over 18. Something I want to be clear about is we are not allowed to simplify this 6 and this 18 the way that it's currently set up. I cannot cancel these out because this is added and subtracted. So here, the square root of 36 times 5, well, the square root of 36 can come out of there as a 6. So I'm going to go ahead and bring my work up here. So I have x equals 6 plus or minus, we have 6 radical 5 over 18. So now what we can do is we could think about splitting this up into 2 separate pieces. So I have x equals, this is 6 over 18 plus or minus 6 radical 5 over 18. So I can take each part of the numerator over that one term in the denominator, and now I can go ahead and reduce these. So I couldn't just cancel this 6 and this 18 previously. I have to split it up in order to be able to do that. So I have x equals a third plus or minus, because again, 6 and divides into 18 3 times. Same thing on this right-hand side. So I'd have the square root of 5 over 3. So this is actually 2 separate answers. So we have the choice of either writing the 2 separate answers. So I have 1/3 minus radical 5 over 3, 1/3 plus radical 5 over 3, or I can write it as one entire answer with the plus or minus in between. So plus or minus the square root of 5 over 3. And just one more note, because we kind of got these weird answers out with square roots involved, we couldn't simplify it down to 2 rational numbers. That means that this original quadratic could not be factored. So this we were stuck solving using the quadratic formula. And before we move on, I just want to give one alternate way to write this final answer here. So since they have the same denominator, I can write this as 1 plus or minus the square root of 5 all over 3. So that final answer has a few different options in the way that we can express it. But the bottom line is it is two different answers. And now the last example here, we'll solve 9x squared equals 42x minus 49. So we have to again move everything to one side to set it equal to 0. So 9x squared minus 42x plus 49 is equal to 0. So our value of a is positive 9, b is negative 42, and c is positive 49. So we're going to have some pretty big values for a, b, and c to substitute into the quadratic formula. So for reference, here's our quadratic formula, and let's go ahead and substitute in our values. So I have x equals negative b, so negative times negative 42 plus or minus the square root of b squared, so negative 42 squared, minus 4 times a was 9, times c, 49, all over 2a, so 2 times 9. So now we're just going to have to simplify this, and these are some pretty big numbers, so we have x equals, well, the negative and the negative is positive, so I have positive 42, and then plus or minus the square root of negative 42 squared. So that's going to be a positive number, positive 1,764. And then I'm going to subtract, multiplying all of these three numbers together, right? We're following order of operations here. So we did our exponent, now we do all of our multiplication, and that also gives us 1,764. And then all over 2 times a, which was 9. So the part underneath the square root is 0. So what I have left here is x equals positive 42 plus or minus radical 0 over 18. Well, square root of 0, that's just 0. So adding or subtracting 0 does nothing at all. So what I'm left with here is x equals 42 over 18. So if I divide 42 by 6, I get 7. If I divide 6 into 18, I get 3. So my one answer is 7 over 3. And because I got out a nice answer, nothing with a square root left, that means that the original quadratic was in fact factorable. So if we factored this original quadratic, we actually would have obtained 3x minus 7, 3x minus 7. So it's the same exact factor. So it's like 3x minus 7 squared. And that's why it's the same value, 7 over 3, and we only got out one solution. So it's possible to get out one solution or two solutions from the quadratic formula, because we can have either one or two real number solutions.